following presentation will discuss some different types of quantitative research methods. It'll focus on descriptive research, correlational research, causal comparative or ex post facto research. It'll also look at time series and a true experimental research design. Descriptive research methods are pretty much as they sound. They describe situations. They do not make accurate predictions, and they do not determine cause and effect. There are three main types of descriptive methods: observational, case study, and survey. The first we're going to talk about is the observational method. With the observational method, animal and human behavior is closely observed. There are two main categories of observational method: naturalistic observation and laboratory observation. The biggest advantage of the naturalistic method of research is that researchers view participants in their natural environment. This leads to greater ecological validity than laboratory observation. Ecological validity refers to the extent to which research can be used in real-life situations. Proponents of laboratory observation often suggest that due to more control in the laboratory, the results found when using laboratory observation are more meaningful than those obtained with naturalistic observations. Laboratory observations are usually less time-consuming and cheaper than naturalistic observations. Of course, both naturalistic and laboratory observation are important in regard to the advancement of scientific knowledge. The second part we're going to look at now is the case study method. Case study research involves an in-depth study of an individual or group of individuals. Case studies often lead to testable hypotheses and allow us to study rare phenomena. Case studies should not be used to determine cause and effect, and they have limited use for making accurate predictions. There are two serious problems with case studies: expectancy effects and atypical individuals. Expectancy effects include the experimenter's underlying biases that might affect the actions taken while conducting research. These biases can lead to misrepresenting participants' descriptions. Describing atypical individuals may lead to poor generalizations and detract from external validity. And now lastly, the survey method. In survey method research, participants answer questions administered through interviews or questionnaires. After participants answer the questions, researchers describe the responses given. In order for the survey to be both reliable and valid, it is important that the questions are constructed properly. Questions should be written so they are clear and easy to comprehend. Another consideration when designing questions is whether to include open-ended, closed-ended, partially open-ended, or rating scale questions. Advantages and disadvantages can be found with each type. Open-ended questions allow for a greater variety of responses for participants, but are difficult to analyze statistically because the data must be coded or reduced in some manner. Closed-ended questions are easy to analyze statistically, but they seriously limit the responses that participants can give. Many researchers prefer to use a Likert type scale because it is very easy to analyze statistics. In addition to the methods listed above, some individuals also include qualitative and archival methods when discussing descriptive research methods. It is important to emphasize that descriptive research methods can only describe a set of observations or the data collected. It cannot draw conclusions from that data about which way the relationship goes. Does A cause B, or does B cause A? There are many types of correlational research. The commonality among all types of correlational research is that they explore relationships between variables. Where descriptive research only described what was going on, correlational research talks about the link between different things. It is important to understand that correlational research does not tell us that variable A caused variable B, but rather that they are somehow related. Before we examine the different types of correlational research methods, understand that correlations can go in two directions, positive or negative. When two variables go in the same direction, that is considered positive correlation. When two variables go in different directions, that's considered negative correlation. Scientists measure the strength of a correlation by using a number called a correlational coefficient. Now, you do not have to know how they get that number, but you should know what it means when you see it. The number range from -1 to +1. If two variables, like studying and grades, have a correlational above 0, like 0.76, then you have a positive correlation, and the more you study, the better grades you have. The number is below, like negative 0.42, then you have a negative correlation. And when one variable goes up, the other goes down, like garlic and dating. If two variables have a correlation of 0, then they have no relationship with each other. The closer the numbers go to either +1 or -1, the stronger the correlation. The strength has to do with whether the number is positive or negative. A correlation of negative 0.88 is stronger than one that is positive 0.56. The closer the number gets to 0, whether positive or negative, the weaker the correlation. There are many different ways to show a correlation between two variables. Let's discuss some of the more popular ways. We're going to look at the survey method and the naturalistic observation. First, we'll discuss the survey method. Perhaps the most common type of research around is survey research. Every time you receive a letter in the mail asking you to take a minute to answer a few questions, or get a phone call begging for 10 minutes of your time to speak about it, how do you feel? You are experiencing the survey method of research. All surveys have one thing in common: they ask questions. Now, there are good and bad things about surveys and research. The good: no matter how you do it, internet, mail, phone, in person, they are fairly cheap. You can cover large populations of people easily if you use the phone or internet. The bad aspects of surveys is that the response rate is really low, and that people can lie on surveys, so you can always question the validity of your data. So now let's break down the survey method as a tool of correlational study. Pretend our hypothesis was that more garlic people eat, the less they date. First, we have to come up with some survey questions. Hopefully, when people answer the survey, they will see that people who have stated that they are eating a lot of garlic have also answered that they have dated less. But who are we going to give the survey to? As with all types of studies, we must choose a sample of people to take the survey. We have to first identify a population of people from which we are going to get the sample. The population includes anyone who can possibly be chosen to be part of the sample. If we are studying anorexic women and their dating habits, we would choose a sample from a population of anorexic women. In the case of garlic and dating, I am going to limit my population to single men and women between the ages of 18 to 25 from the Westchester area. Now, how do I pick people to be part of my sample? Do I call all my single buddies in the Westchester area and give them the survey? That would not be a very fair way of doing it. To make the survey valid, I must randomly select a sample from the population. Random selection means that every person in my population has an equal chance of being selected for the survey. If I can do this, then my sample has a great likelihood of actually representing the larger population. How do I randomly sample my population? I can randomly pick names out of the phone book. In other words, finding a truly random sample is not easy. Naturalistic observation, on the other hand, is another correlational research method. Naturalistic observation is when a researcher attempts to observe their subjects in their natural habitat without interacting with them at all. Pretend I had a hypothesis, such as marijuana increases hunger. If I wanted to use naturalistic observation, I would find a bunch of pot users and watch them. I would follow them around to parties, watch them smoke, and then see if they eat. I would never interact with them, but just watch. If I see that every time a pot user smokes they eat, I would claim that smoking and eating are related. But I would never know if the smoking caused the eating. Once again, at most of these types of studies show correlation, the pinnacle of all science is to prove causation. Ex post facto research is systematic empirical inquiry in which the scientist does not have direct control of independent variables because their manifestations have already occurred or because they are inherently not manipulated. Inferences have relationships among variables are made, without direct intervention from co-commitment, variation of independent and dependent variables. This kind of research is based on a scientific and analytical examination of dependent and independent variables. Independent variables are studied in retrospect for seeking possible and plausible relations and the likely effects that the changes in independent variables produce on a single or a set of dependent variables. Time series research design is another arm of mathematical statistics that statisticians can use to aid the development of your research studies. Some fields which can benefit from time series research design are those in the business and finance realm, such as economic forecasting, stock market analysis, and yield projects. Of course, labor industries also benefit from time series research design in the form of workload projections, longitudinal studies, or utility studies. Through time series research design has many applications. There are two central goals of any such study. First, identification of the nature of a particular relation or phenomenon must occur by analyzing occurrences of observations as sequences. Secondly, forecasting can be accomplished by examining these patterns to predict future time series variable values. Of course, before either goal is accomplished, the observed time series data pattern must be first identified and described in detail. Interpretation and integration of data can then subsequently occur. Independent of theory, future predictions can be made from such data analysis. True experimental design is regarded as the most accurate form of experimental research, in that it tries to prove or disprove a hypothesis mathematically with statistical analysis. For some of the physical sciences, such as physics, chemistry, and geology, they are standard and commonly used. For social sciences, psychology, and biology, they can be a little bit more difficult to set up. For an experiment to be classed as a true experimental design, it must fit all of the following criteria. First, the sample groups must be assigned randomly. Second, there must be a viable control group. Third, only one variable can be manipulated and tested. It is possible to test more than one, but such experiments and their statistical analysis tend to be cumbersome and difficult. Lastly, the test subjects must be randomly assigned to either control or experimental groups. The results of true experimental design can be statistically analyzed, so there can be little argument about the results. It is also much easier for other researchers to replicate the experiment and validate the results. For physical sciences working with mainly numerical data, it is much easier to manipulate one variable, so true experimental design usually gives a yes or no response. While perfect in principle, there are a number of problems with this type of design. First, they can almost be too perfect, with conditions being under complete control and not being representative of real-world conditions. For psychologists and behavioral biologists, for example, there can never be any guarantee that a human or a living organism will exhibit normal behavior under experimental conditions. True experiments can be too accurate, and it is very difficult to obtain a complete rejection or acceptance of a hypothesis because the standards of proof required are so difficult to reach. True experiments are also difficult and expensive to set up. They can also be very impractical. While for some fields like physics, there are not as many variables so the design is easy, for social sciences and biological sciences, where variations are not so clearly defined, it is much more difficult to exclude other factors that may be affecting the manipulated variable.